parallelograms. Okay, we're going to recognize and apply properties of sides and angles of parallelograms. We're going to recognize and apply properties of the diagonals of parallelograms. So this is right here. Anybody know what this is called right here? Yep. That's a basketball thing where Diego likes to slam dunk it. Okay, so sides and angles of parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. To name a parallelogram, use a symbol. You see this thing right here? Like a slanted rectangle. Okay, so we can go ahead and say this right here, like for this one here. In parallelogram ABCD, okay, you can kind of, that symbol now means parallelogram for us. So in the parallelogram ABCD, you have line segment BC parallel to line segment AB. So that one's parallel to that one. And that shows you, remember the back in the old days, we had one arrow, and it was parallel to any other line segment that had one arrow. And same thing for these. Since these have two arrows, these are both parallel to each other. And AB is parallel to DC. Other properties of parallelograms are given in the theorems below. Okay, so here's parallelogram JKLM. So look, if a quadrilateral, four sides, is a parallelogram, then its opposite sides are congruent. So look at JK. Its opposite side would be the one across it, ML. So those are congruent. JM, opposite sides, KL, congruent. Going once, going twice. Okay, now if a quadrilateral is a parallelogram, then its opposite angles are congruent. So a K and angle M, you see how they're opposite of each other? Congruent. Same thing for angle J and angle L, congruent. Okay, so do me a favor, guys. Here's the definitions. Here's the information that you need. Opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. I'll give you a couple of, like a minute to draw this stuff down, write it down. Very important that you get the ideas of the pictures, okay? Once you get the ideas of the pictures and you know that this one hash and this one hash are, you know, meaning they're congruent, then these two are congruent, and this automatically explains this. Same thing here. One arc across one arc here means those are congruent. Two arcs here across these two arcs means those are congruent. And that happens with parallelograms. So, moving on, there's some more theorems here. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Remember, supplementary and complementary kind of go alike. Supplementary means that they add up to 180. Complementary, C comes before S. Complementary means that they add up to 90. Consecutive means that they're right next to each other, like this, okay? You usually name triangles or angles or whatever you want to talk about in order 1, 2, 3, 4. So that's why they connect like this next to each other. So this one right here and this one right here, supplementary. This one right here and this one right here, supplementary. Look at this one, consecutive, supplementary, supplementary. And then if you look at the ones that are next to each other, supplementary all the way around. Now, if you can kind of look at this real quick, that kind of is the same thing if you think about it. Well, aren't these opposite? Didn't we just talk about opposite angles, congruent? And these are opposite congruent. Well, obviously, if these two, then these two. You know, it's just a no-brainer. If a parallelogram has one right angle, then it has four right angles. And it has to, it's a no-brainer if you think about this one. This one's 90, so there's several ways of looking at it. The opposite angles are congruent, so this is also 90. Now, the ones next to each other have to be what? Supplementary. Well, they all have to be what, 90? This has to be 90. This is 90. That one has to be 90. So they have to be all be by 90. Any way you look at it, any way you cut it. Everything holds true. Going once, going twice. I'll give you like another minute to copy these down. You want to combine them, space and space, whatever it takes, get it done. Give it about a minute. I'll give you 2 minutes to copy this down. Okay, so let's come to example number 1. Now again, a basketball court right here. A Okay, the way you read this one again is in parallelogram A, B, C, D. Suppose that measurement angle A. I'm just going to kind of throw these things over here. Measurement angle A, which is this inside part here, is 55. AB, line segment from A to B, is 2.5 feet. BC is 1 foot. From here to here is 1 foot. Find each measure. DC. Okay, DC is from here to here. Now remember, if this is a parallelogram right here, and it's telling us it is, then we know that this one's equal to this one. So AB is congruent to DC, right? So there it is. If we know that AB is 2.5, then we know that DC is 2.5. Find the measurement angle B. Angle B is over here, right? Okay, so if that's 55 degrees, then we know they can say the opposite angles are 55. So you can say this is also 55. That didn't help me out at all. But what I do know is these two together slash these two together are supplementary. So I can set that up. 55 plus angle B is equal to 180. Subtract 55 from both sides, and I'll get angle B to be 125. So we'll go with this one to be right here, 125. And I guess I'll put degrees so we can see that they're angles. Going once, going twice, not too bad. Find the measurement angle C. Okay. So remember, angle A is 55. So this one here is 55. And the opposite side, opposite angle from A is angle C. It's also 55. So there's that one. Going once, going twice, pretty easy, right? Look at the comments, guys. Pretty easy. Do you have any questions over it? Do y'all need help with it? Okay, I wouldn't insult you guys like that. Basically, I'm saying it's too easy. Do me a favor. Let's go ahead and copy down. At least draw the. Yeah, you don't have to draw all this thing. Just draw this parallelogram and put this, I guess, right, that it is a parallelogram, and then say that the angle J is 47, and let's find A and let's find B. So again, just draw a real kind of cheapy a parallelogram. Make sure you do need to say that it is a parallelogram. You do not have to draw this mirror, right? That kind of extends to help you out. Well, what you're going to say, okay, that, knowing that angle J right here is 47, let's go out here for number one. Let's find A. Where's A? Let me see. A is asking for find the measurement of angle L. Okay, so J and L opposite of each other is 47. Not too bad. Measurement of angle M. Okay, M is right here. Okay, so make sure you know opposite ones are congruent and next to each other, either way you look at it, are supplementary. So I'm just going to do it the way the book did it. Measurement of angle M plus, I want to go with 47, is equal to 180. So remember, I want to go, if you don't mind, I'll just look at these two like this. I'm looking at these two. When I add these two up, they equal to 180. Okay, and that's it. So now regarding this part, I'm going to say, well, I can figure this out against simple algebra by subtracting 47 from both sides. And we're going to go with the measurement of angle M is equal to 40, 33. He's gone. All right. Let's go on here. C, letter C now. Suppose the arm was extended further, so they extended this arm, okay, so that the measurement angle J, where's angle J? This one right here, is 90 degrees. What would be the measure of each of the other angles? Seriously. Remember this idea? Anybody know the answer for this one? So if this one's 90, just say this one's 90 now. What would each other measure be? Going once, going twice. Somebody. Just 2. Yep, 90 degrees. Going once, going twice. Okay, guys, thank you for answering that question. Let's come over here. Glad you could join us, Raven. Glad you could join us, brother. Okay, diagonals, guys. Diagonals of a parallelogram have special properties as well. Now, this one's cool. Parallelograms, guys. Everything kind of, if you think about it in my head, everything kind of equals out. Parallel, kind of the same. So here you go. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So if you look at this diagonal here and this diagonal here, so when you draw that line from here to here and that line from here to here, when they cross each other, they cut each other in half, if that makes sense. So from D to B, it's, just humor me, it's, I'm going to go with a nice even number. Say it's 8. Okay? And from A to C, a nice even number, say it's 10. But when they cross each other, now this one only becomes 4 and 4, and this one's 5 and 5. Still stays 8 together, still stays 10 together, but now as far as when they cross each other, they bisect each other. Again, bisect cuts in half. Next one, if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into 2 congruent triangles. So if I have this parallelogram here, and I have a diagonal here, then I have this one triangle here, all right, congruent to this other triangle over here. So basically cuts it in half. Really sweet, really cool. Now look at the way it works out here. Look at the way this one works. So this angle has to be congruent to this angle. This angle here has to be congruent to this angle here. This angle here has to be congruent to this angle here. Well, how does that work? Because if this is a parallelogram, think about this. This here would be your, what is that called? Transversal, right? And these are your alternate interior angles. Pretty cool. Now when it comes to this, look at the way we go here. Like they kind of like reverse the congruency, if you think about it. Not the reverse the congruency, they reverse the order to name congruent triangles. So triangle ABD, A, see I'm going like this, BD, is congruent to CD. Okay. So you see this one comes here and I'll go there. It's like the yin and the yang. Okay. So for us, when we have a parallelogram and it's cut in half by a diagonal, then just name them kind of like going like in the opposite directions. Or I could name it another way. I could go like this. You see this? And then do what? And that would still be congruent. Okay? You just can't name them both like this. Both going in the same direction. You see, that's kind of wrong. So sky's the limit how you want to write this one down. But please make sure if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into 2 congruent triangles. Diagonal separates a parallelogram into 2 congruent triangles. I'll give you about 3-4 minutes to copy this one down, guys. Okay, guys, let's use this to our advantage. Remember, diagonals bisect each other. And remember that when the diagonal is, drawn, it separates the parallelogram into 2 congruent triangles. So use properties of parallelograms and algebra. What? Sounds like fun already. Okay, let's look at this one real quick. If QRST is a parallelogram, find the value of the indicated variable. So if you look at this one, remember diagonals and opposites and all this stuff, okay? So this one's equal to that one, I know that for sure. That one's equal to that one. Angles, I know this angle is equal to that angle. I know this angle is equal to that angle. I know this diagonal and this diagonal bisect each other, so this half is equal to that half is equal to that half. What else? Oh yeah, angles that are next to each other. So this angle here and this angle here are supplementary. Sorry about that, guys. I saw the chat going on. So let me start that again. So real quick, if QRST is a parallelogram, find the value of the indicated variable. So when it comes to this part real quick, you have this parallelogram here. Remember, all the properties still hold true. If it's a parallelogram, opposite sides are equal to each other. Opposite sides are equal to each other. Angles that are opposite, this whole angle here and this whole angle here are opposite or equal. This opposite angle and this opposite angle are equal. Diagonals bisect each other, slash this side is equal to this side, or this half is equal to that half, so forth. Okay, going once, going twice. So use that all to our advantage and see what's going on. So they want to go and find the indicated variable. What's the variable they're asking for? X. When I look at X, X is over here. Okay, when I know this one is equal to that one. And you just say that and set it up and work on that. And there it is. QT is equal to RS. 5X equal to 27. Do your math. There you get that. Y. Let's look at Y. Where's Y? This Y right here, this one's side length is 2Y minus 5. This side length here is a Y plus 4. Now when it comes to these two, think about them. This one and this one, the diagonals bisect each other, so this half is equal to that half. So 2Y minus 5 is equal to Y plus 4. I get Y to be 9. Last one the same. Find Z. Okay, there's different ways of working this one out. But I'm going to just show you the way they want you to do it. So make sure you know this triangle, okay, this diagonal, you see this? Cuts this parallelogram into two congruent triangles. I'll go like this. You see that? Draw them like this. So what I do know now, I know that this angle here is equal to this angle here. Okay? Now when it comes to that part right there, I'm just going to say that 3Z is equal to 33. Remember, this would be if I had a parallelogram and this would be my diagonal or my transversal, then these would be my alternate interior angles and they'd be equal. So that angle, let me see, let me zoom out. Zoom out some more. Okay, so TQS, so they went the other way, my bad. This angle, triangle like that, TQS, and RSQ. RSQ. So that one's equal to that one. This one's equal to that one, and that final where they end up is equal to the other one where it ends up. So those two are equal to each other. Slash 3Z is equal to 33. Divide by 3, Z is 11. Going once, going twice. Okay, let's go and try this one out real quick. Hey, remember you have your test right now. You on? Oh, it's a little science. Find the value of each variable in the given parallelogram. So 2a right here. You can find the value of each variable in the given parallelogram. 2a. We have this parallelogram here. Draw it out real quick. Label it real nice and fancy. Okay, so find the find the value of each variable in the parallelogram. So let me see. We'll go with X first since alphabetical order. So when it comes to X, let me see. I have X referring to this angle. I know this angle is equal to this angle here. I know this angle is equal to this angle here. What do I know about these two angles? They're supplementary. So when it comes to finding the X, I'm going to say that one for X plus 2X minus 6 is equal to 180. And solve it from there. It becomes 6x minus 6 is equal to 180. Add 6, 6x equals 186. Oh, great. What is that, 31? x equals to 31. So 6 into 18 is 3. One more 6, yeah. Okay, let's go and try y. When we solve for y, let's see how we do y ideas. Okay, so this is referring to a side length, and our side lengths are equal to each other. So now, basically, that's it. We're going to go ahead and go with y plus 8 is equal to 5y. Let me see, minus y, move the smaller y's, only 8 is equal to 4y. Divided by 4, divided by 4, y is equal to 2. Okay, fine. It's been like months, it feels like. To be or not to be? That is the question. But okay, guys, so let's go ahead and do to be. Anybody know how to do this one? To be. Come on. Somebody. Help me out. That's it. Thank you so much, Diego. Since this is a parallelogram, it's telling me that. And it shows me that this diagonal and this diagonal are drawn to each other. Well, when I have this intersection part right here, it basically makes this one and this one equal to each other. It bisects. Okay? They bisect each other / cutting these into equal halves. And again, Diego had it right. Set them equal to each other. And then we're going to go ahead and move the smaller z amount, minus z. Cancels out here. We'll go with 2z minus 4 is equal to 5. We're going to add 4, add 4. Cancels out here. 2z is equal to 9. Did I do that right? 2z, 4, 9. Okay. Z is equal to 4.5. Okay, what do y'all think on that one? Not too bad. Thank you, Diego. Thank you, Alina. Thank you, Eileen, for commenting this morning. Keeping it real. Eileen, I'm lost. I'm showing it again. Yeah? Can you see it? Okay, guys, you have an Alex assignment. I believe it named it 6-2. Hopefully I named it that. I think I went to 6-3. We're going to get that done right now. You have about 30 more minutes in class. Okay, lies. 23 minutes. Forgive me. Took too long. I'll be here. Try it out. It's really easy. Remember, tomorrow we are testing. We're going to test over chapter 5.